For what?
Fancy football.
Oh. I'm on like a 6-game losing streak.
What was your team name this year?
Started off with Tainted Bloodlines.
Oh boy.
Now we switched to Stimulation Nation.
Stimulation.
That's actually more of an inside joke for somebody else's team, but he didn't want to change his team name, so I changed mine to the team name his should be. Okay.
This is the right team.
This is the correct team name. So for your homework, did we write,
We did parse time, but not the apply expression.
here's our add expression. So we did apply expression, but up in parse Simon, we wrote a math expression. Instead of an add expression, we changed it to a math expression, right? So a math expression has 3 pieces of information. One of the things is an expression. Is an operator, and then the other thing is what's up?
We haven't updated it yet, so that's just the 2.
Yeah, it's just the 2 numbers.
Oh, so we kind of like ended right here. So I need to finish this. That's what you're saying. Okay. So a math expression is going to look like what? It's going to look like, it's probably still going to look like something like this, but we need to pull the, did we do an is operator already? Oh, we did an is math expression. Where do we write that? Huh? Oh, it was a let. Ah, here we go. Is math expression. Takes in a single parameter. If it's a plus, a minus, a divide, or a times, it should return true. Perfect. So if that's true, then we want to create a list whose first element is a math expression, and then whose second element is a list, whose first element is the... Actually, whose first element is just the catter of the expression, right? Whose second element is the CADDR of the expression, and whose third element is the CADDDR of the expression. Right? That's a list with operator, first number, second number. Actually, no, it's just, this is just the car, the expression, catter, like that. That'll do it. Make sense? So we're going to create a list saying something is a math expression, followed by the second parameter will be a list whose first element is the operator, second element is the first number, third element is the second number. All right, we should be able to test this with this SE7. So let's run this and make sure the dude looks legit. Here's our math expression. The math expression, it's a list whose first element is a math expression. Second element is a list, and in that list, the first element is the operator, then a var expression, and another var expression. Cool? All right, so now that's and we'll see that this guy will work for, let's just test him for all the different, let's try it as a subtraction. There's our subtraction math expression, multiplication. There's our multiplication math expression, and division. There's our division math expression. And then you were supposed to update, apply expression. So instead of looking at a add expression, we're going to look at a math expression. And which math expression we're going to do, we're going to have to create another function here called define apply math expr, and this guy is going to be a lambda that takes in an operator, a num1 and a num2. I actually think that will work. I think we can just apply the operator to that. Let me actually quickly test this. Apply math expr. Let's pass it the plus sign, a 4 and a 5. Yeah, it didn't like it because it's quoted. All right. Well, couldn't do it the stupid little easy way. Not a big deal. So we'll create a little cond. If op eqv op plus sign then boil down to plus num1 num2. I'll steal that line. Minus sign is minus num1 num2. Yeah, I'll have to quote them. Multiplication. And division. So these need to be quoted over here. Okay. Well, then we have to have it else. We'll just boil down to false if you call it with the wrong crap. Okay, so that's apply math expression. And we should be able to test this now. Apply math expr plus 5, 4. There's our 9. Let's do it with the minus. There's our 1. Okay, I think we're good. All right, so that's our apply math expression. So then we can just finish up this guy. We're going to call apply math expr passing it the CADR of our Basel code. That's our operator. So let me kick this down the line. Followed by, I want this. I want that, and then I want this to be 1 and the other one to be 2. Like that. All right, so now we should be able to call apply expr, passing it that Basel code and empty env. Is that how I spelled it? Yep. And for right now, we should get 5 divided by 7. Here, let's just multiply it for starting point. There's our 35. So now let's add. There's our 12. Now let's subtract. Should be -2. And then divide should actually be 0. Oh, it does integer, or does floating point division. It's probably one of the settings up here. All right, that makes sense? So that's what you were supposed to do for your homework. Who got it working? Well, that's getting better. Who tried it but didn't get it working? Who really tried it and didn't?
I did.
Skippy, I saw you like 40 minutes ago, and you're like,
I went in there.
it's like,
I was in there.
40 minutes ago you were asking me, did we have homework?
I actually made it worse than it was before. Now this whole method doesn't work.
Really?
Yeah, I don't know why.
Did you learn anything in the process?
But I suck.
What?
That I suck.
Well, I don't know. I think if you made a decent stab at this but didn't get it working, I wouldn't say that necessarily means that you suck. If you at least had an inkling about what you were supposed to do, rather than Skippy, who wanted to know if we had homework, even though he could have just logged into Angel.
No, I went and did it since I saw we had homework. Or I attempted. Right.
Okay, so now our language allows us to have a local let environment. We can then do math type functions. Now, what's the difference between a let and a let star?
Let star, you can reference other things that you've already defined within the let.
Okay, how would we implement that? So right now we have a let. Here's our let expression. And a let creates a list for a var_def expression followed by a list with all of our parameters in it, right? Would we change anything for that if we were using a let star? Would you say that a let star is like a let but better?
Yeah.
Okay, so I'm not necessarily advocating that our language, our Simon language, should have two different ways of defining it. I'm saying that we should maybe re-evaluate the way we wrote our var_def expression to work as like a let star instead of like a let. What would we need to change? So right now we can just do this. We can just add a star in here, right? And now we support, well, not like that. Now we support let stars. Okay, so now our language breaks. By that one little symbol, we no longer can do stuff because we're trying to parse this guy down here. But we could fix it real quick by fixing our Simon syntax and changing that back to a let star, and then we're back in business. Okay, but now so we've changed it to a let star for no good reason other than the fact that we just want to be reminded that we're making this guy work differently. The reality is, since this is our Simon language, we didn't even need to call it a let. Right? We could have called this a SENV, Simon environment, or something like that. Okay, but we'll call it a let star, so we're at least keeping our brains relatively unscrambled. So that means that if I had a let like this, I should be able to say A equals 5 and B is equal to plus A2. I should be able to do things like that. How do I add support to my language for that? We need to now again upgrade our language. Well, right now, how does it work? If we are in our apply expression, which takes in our Bazel code, which is the output of our parse Simon, right? And I find something that is the var_def expression, which is going to be my let star now. What am I doing? I'm calling apply expression, passing it whatever's at bucket 1 of that, which should be what? Well, bucket 1 of the catter, which should be our list of variables, kind of our environment. And then whatever, actually, no, this is our environment. We're adding scope here. So that's where we're doing our environment. And then this guy right here is the Bazel code that we're applying. All right, so this is where we add our scope. How would we modify this code so that it works like a let star. What does a scope look like? So right now our scope looks like this, so that bucket 1 is that guy right there. That's what it looks like. We're defining two variables. The first variable is named A and has a value of 5. The second variable is named B and has a value of whatever A is plus 2. How would I modify my code to now support that? By show of hands, let's start with this way. How many people think that this is going to be pretty hard? Maybe there's two questions there. How many of you suspect this will be hard versus how many of you think this will actually be hard? Realistically speaking, this probably is not going to be hard because few of the things that we've done actually are hard once you see the right answer, right? But at first glance, like, oh, well, this throws a whole nother wrench into the engine, right? How would you maybe do this? Somebody other than Jake. What's preventing us from making this work right now? Why can't we define B in terms of A here?
They're in the same. What if we just separated them into different lists? Would that work?
Say this again? Oh, you said, what if you separate them in different lists? Okay, tell me more about that.
Just put it a layer deep so they're not in the same scope. So that
Make two scopes.
it does the first one, and then it goes to the next one. That
It
one
treats
does
them
the
as separate scopes. That's what you're saying? Okay. So, in this particular case, rather than adding a single environment to our scope, you want to make a scope that is just that variable, and then a second scope that is just this variable. Right? Okay, how will we do that? A who? Oh, well, I mean, we could force the code to work that way. No, I understand what you're saying. You're saying change our assignment code. So rather than saying let like this, we would have a let, and then inside that let, we'd have another let, and then inside of that, we'd divide A by B. Yeah, you could certainly write your assignment code to make this work the way we want it to work. But I'm saying I want our single let to allow us to define multiple variables in terms of each other. How do I take this list like this? So I want something that looks like that. And I want to turn it into what? I want to turn it into that and that. Two separate variable environments, right? Here's a variable environment that has exactly one variable in it. Here's another variable environment that has exactly one variable in it. And I'd like to add them to my current environment in this order. Add this dude first, so he's available, then add this guy. That make sense? Well, for starters, how do I take something that looks like this and turn it into something like that? Let me just wrap this whole thing inside of a list. So how do I take that to list, so it's a list with two elements in it, and turn it into this to list, which is the same list with two elements in it, but each of those elements now is wrapped inside of another list? First of all, does this look familiar to you? from way back in the semester as we talk about patterns. I think the name of the function was up. Remember that guy?
Remember that movie?
I do remember that movie. Pretty sure there was a episode of Mythbusters where they tried to recreate that.
Really? Did it work?
Yeah.
What?
I spent actually quite a bit of time on Mythbusters' website last night. This could be a quiz. True or false?
False.
If you remember that.
Okay, what's the answer? Or what's the question?
What's the answer?
Your grade depends on it. It probably doesn't
Worst
matter.
Jeopardy,
This is worse Jeopardy. Okay. True or false? You can sneeze with your eyes open.
False.
True. What? True. What?
How many of you in here? Well, first of all, it is true. Because I can sneeze with my eyes open.
You cannot.
Mm-hmm.
You can.
If you go like this.
No, I can do it without no hands. No hands. And the thing is, the really stupid thing is that at one point when I was a lot younger, I thought I heard that you couldn't sneeze with your eyes open, so I decided to put that to the test. So I trained myself to sneeze with my eyes open. Who else in here can sneeze with their eyes open?
Obviously not me.
How many of you don't know if you can sneeze with your eyes open?
I don't.
Hey, what are you, idiots? You don't know how to write programming language, and you don't know if you can sneeze with your eyes open? Yeah, I mean, I squint a little bit, but I mean, I can do it. So the question is the myth is that you can not sneeze with your eyes open. The reality is you can. Well, then the question is like, okay, well then is there a risk that your eyes will pop out? There isn't. Apparently they're in there pretty good.
Unless it gets smoked by a tennis ball.
Right. No, his eye didn't pop out, it just popped.
Well, I bet it could ooze out then.
Yeah, there was some liquid. It's true.
Gross.
Yeah, but isn't that interesting? I don't know what did I think about that?
Why were you on the Mythbusters website extensively?
Because they did a test on that, whether or not you could sneeze with your eyes open.
Oh, long time ago.
Yeah, a long time ago. I had a sneezing fit at the house last night,
Oh,
and they made my wife take a video of me sneezing with my eyes open.
we got the video?
And she has it.
Should never send it to you.
Last night she also emailed me a audio clip she took of Gracie snoring. Gracie needs a CPAP machine just like me. All right, what were we talking about?
Oh, oh
Oh.
my god.
On that fifty.
Why are these the house?
Do you think you want to mention that Gracie's stuff
Why would I ever stuff?
when that fateful day comes?
She's immortal. See, you would actually, for those, if you would have shown up to the Solly's breakfast the other day, we went through, how many of you have the speed test app for iPhone or Android? Do you know the Easter egg in there?
Joey showed me that.
Yeah, so you can swipe down on it and it shows this guy, his cat. He has this evil cat. And apparently the cat died earlier this year. And it's like a whole storyline. Just keep swiping down. It changes pictures of the cat. And this cat literally looks evil. And so then, there was the last several pictures we're talking about, how sadly after 14 years or something like that, he has passed on. Rather than thinking about this as death, we rather think of it as his final form or something like that.
And then it said something about like, so now he like haunts.
Oh yeah,
it's like-
should you be afraid? And you keep going down. There's nothing in there. Yes. So
Where do you sort it down,
on the do the test and then you swipe down on the meter thing, the result. All right, so we need to write a function that takes something that looks like this and turns it into something that looks like this. Right? Okay. Well, how do we do that? We need to write up. Well, we've done that a long time ago, so let's write up. Let me take this apply expression thing off here so our world doesn't end. I think this should run right now. Good. Okay. So I'm going to define up test to be a list containing A, B, C. And we'd like to have a list containing the list A, the list B, and the list C. Correct? All right. So, everybody take out a piece of paper.
Come on.
How did you find this?
Yeah, how is this Easter egg found?
This is hilarious.
This was like leaked.
No, it's been there since the very beginning.
Really?
Yeah. I remember I stumbled upon it. The interface used to be simpler.
Oh, really?
So it was like more, it wasn't like you would search for an Easter egg, but it was, you can more accidentally do it. Okay, so here is the start of our function up. So write up such that it takes something that looks like this and produces something that looks like that. Make sense what I'm asking you to do? Extra credit for anybody who can finish this in under a minute. I'll give 5 minutes for the rest of you. 1 minute should be more than enough time to finish this based on what you guys know.
I'm not a right word, so.
Try to cheat off on me.
Watch it here.
Nobody else is done?
I am.
No? Who finished in under a minute?
Oh, me, totally.
Is under a minute? That's not the under the minute solution.
Should be close.
Is this the under the minute solution? Not the under the minute
I
solution.
don't think so.
Is this the
Pretty
under the
good.
minute solution? Not the under the minute solution. Not the end of the minute solution.
Breakdown doesn't work. Dumb today.
I don't know, I didn't look at it, but it's not the end of the minute solution. Is this the end of the minute solution? Not the end of the minute solution.
Spent. Why is Yahoo my default search engine? Riley's Irish Pub? No.
the under the minute solution?
One more parenthesis for good measure.
One more parenthesis for good measure?
We are all far too stupid.
Huh?
We are all far too stupid.
Oh, Drake got it.
I am far too stupid.
You think you got it now?
No, I forgot the name of the function, but
Isn't there a built-in function?
To do with the under the minute solution, probably.
Yeah, I was gonna say.
All right, anybody still working on it? All right, let's have them down this way.
Oh,
It was the math function.
But I didn't know how to.
oh, I forgot what I did. It was a long word.
You did what?
Just wrote map list. But you need to take a map parameter and a function. So even that.
I think it's the other way around. So map a function
Well,
onto
it
a
takes
list.
in 3.
At least I think it's this. Map the list function onto the list. So I should be able to call up on uptest. It gives me those guys. So there's up. Remember correctly, I think that was a 3-star question, or at least a 2-star. That used to be a 2-star.
I feel like those stars are
We
just
didn't have
bogus.
the map function at that time.
Yeah.
Those just represent nothing.
Hmm. Could have written your own list function. Should we do another quiz? Do this with the map function if you're not allowed to use the list function? What would you do? Let's just say I wanted to rewrite this, but you're not allowed to use list.
Make a helper function.
Yeah, make a helper function.
I'll help her.
Define beef to be lambda, takes in a val, and does what? Cons val onto the empty list. And then map beef.
What else would beef do?
There, done. Also under a minute. Does that make sense? Okay, so we have this function up. Now, we have something that looks like this. And we want each of these to be a scope, correct? So we want each of these to be a scope. How do we get each individual one of these guys out of here? Okay, so we have an issue. We have something called, what is it, add scope? Yeah, here, add scope. Add scope takes in a brand new scope, which is a list of 2 lists, right? And a current environment. How do I add this guy as a scope? Well, I'm sorry. How do I add this guy as a scope, then this guy as a scope, then this guy as a scope? That's what Tina said you want to do, right? You want to break them out into individual scopes, and then add each one as a scope, correct? So in the end, if you started off with the empty environment, you want to do this. You want to say add scope, the list containing the list A. Oh, here, we can actually do this. To the empty environment. Here, I'll actually use the word empty environment. Empty env. Was it add dash scope? Yep. Okay, so there's our updated environment. Then what are we going to do to that? We are going to add another scope. The list, take the list B, onto the environment return from that add scope, which gives us that. And here, I'll get rid of the up test for a moment so it looks cleaner. So now we have a list containing two scopes. Here's our most local scope. And here's our most global scope. Make sense? And then we're going to call add scope, passing it the list containing the list C onto whatever's returned by the add scope on the add scope, which should give us the environment containing 3 individual scopes, with one scope being C, another scope being B, and another scope being A. So treating each individual variable from our let as its own scope. That make sense? Okay. Well, how do we do that? How do I take something that looks like this, or in our case up here, something that looks like that, and create 2 separate scopes from it, adding this scope to our current environment first, then this scope to our current environment? So I've updated this a little bit. Uptest is now a list containing a variable definition, another variable definition, and another variable definition. Calling up on it gives me a list that looks like this. This is a list of what? List of scopes. This is a list of scopes. And what do I want to do with each of those scopes? I want to add the scope to my current environment in order, starting with whatever the current environment is and ending with the environment that continually builds up. So I need to create another helper function for adding lists of scopes. So underneath add scope, let's define add scope list. Add scope list, it's going to be a lambda that takes a list of scopes and an environment. Then if null list of scopes, then do what? Boil down environment. Let me kick it down a line. Otherwise, do what? Called add scope list. to the cdr of list of scopes and add scope, the car list of scopes with the current environment. What does that guy that I've highlighted boil down to? An environment. So I'm going to call add scope list again, passing him all the scopes except for the first one, along with my new environment that was created by adding just the first scope to it. And we're going to do that over and over and over again until we finally run out of scopes, in which case we will just boil down to our environment we've been building up. That make sense? I'm going to go ahead and I'm going to move up. Up, up. I'm going to move up, up. Put it up here. And then we need to come down to apply expression. So in a var_def expression, we're going to apply our expression, passing it the expression, the body of the letrec, or the body of the let star, along with not add scope, but add scope list of what? Here is our scope that we had before, correct? But I don't want just that scope. I want the up version of that scope. Does that make sense? So I am applying an expression. What expression? The body of the let star, on applying it with the environment created from add scope list, passing it the up version of this scope. So if I had 3 variables defined, I would create 3 scopes out of it in the current environment that we're building it onto. That make sense? We do have a small problem right now. Just for the sake of argument. Just for testing purposes only. I'm going to take out this plus A2, and I'm just going to put in A. And we'll go ahead and just add. Just to keep it simpler. Still have a problem. Just to keep it simpler. So the hope is that A starts off as 5, B is equal to whatever A is equal to, which should also be a 5. So we should get a 10 out of this, right? So I'm going to call apply expression, passing it SE7 and passing it the empty E and V as our starting point. And we have a problem. Why do we have a problem? We have a weakness in our environments. Let's go up to resolve variable. Resolve var does what? It takes in a symbol that we're looking for, a variable name, and an environment, a list of scopes. And it does what? It looks we're going to have to look at process scope for a second. Go up to process scope. Process scope takes in a variable name and an individual scope. Okay? Where an example of an individual scope might be this guy, right? That's an individual scope that we're looking at. In our more recent example, an individual scope would be no bigger than a single variable, but scopes are allowed to be lists of 2 lists. Make sense? we go, process scope. So if we're out of variables to look at in this particular scope, just return false. Otherwise, if the first variable name in there matches the variable we're looking for, return its value. We have a problem. This guy right here assumes that that value is always a number. Right now we have a language where a scope is always a variable name followed by a number. Where we're trying to create something that has a variable name followed by a expression. We'd like it to work for var expressions, like a. We'd like it to work for what? Really any expression. But math expressions is the other example we've seen, right? Okay, how do we do that? S is the name of the variable we're looking for. So, for instance, if we were trying to resolve A, well, we would never actually get to that. If we were trying to resolve A from over here, we would do process scope. Well, we would do process and or var ref, whatever it was called. Let me just use the name right. Yeah, we call resolve var. Resolve var would operate across a list of scopes. And for each scope, we would process the scope. So we would be resolving this var eventually on this scope. And it would find that we have a variable whose name is A, which matches the guy we're looking for, and ultimately boil down to the 5. But let's say we were looking for B. If we're looking for B, we would boil down to the B, or we'd find the B, and boil down to its value, which is A, which is not a legal value as we have our environment currently written. We would then need to go and look up A. Correct? Well, where am I going to look up A? Really, there's two questions. Where am I going to look up A, and when am I going to look up A? Okay, I'm going to have to look up A in some other scope other than me. A scope that already exists. Correct? Which is how a let star is going to work. So it's got to be one of the guys behind me. Some scope has already been set up. But now, the time I'm looking for B, I'm inside process scope. I don't have access to the whole environment. Do I? So at this point, it's actually too late for me to look up B. Or I'm sorry, to look up A to get the value of B. I don't have access to the environment anymore. If I was going to resolve B to the value of A, where A is 5, I needed to do that before I got to that point. Because I no longer have access to this guy.
You pass previous environments in as a parameter?
I guess you could. Give it the global environment, just say, okay, look, I know there's a lot of environments going around here. We're throwing a lot of environments around. But look, this is the main one. We haven't touched this, but even within that. So the short thing is you probably could figure out a way to solve it that way. But the danger in that is you need to make sure you only pass in the subset of that environment that is related to the scope you're currently working with. Go ahead.
Would it help to somehow go backwards through the environment? Find out what you have to define and see if that variable is actually there to be used?
Well, in order to add this ability into our language that we're adding right now, we know that in order to define something in terms of something else, at least for that starting point, we know that we need to add these scopes one at a time. So what we really need to do is we need to identify the value of a variable at the time we are adding a scope and decide if we need to resolve that value. So there's almost a pre-processing of variable environments. Not just resolving the value of a variable at the time that you use the variable, but resolving the value of a variable or the value of an expression for math expressions at the time that we define the scope. Does that make sense? So now we're starting to get into some kind of like compiler type stuff. You know, in order to have access to the value of A at the time we're defining this variable B, I need to look up A right then. Does that make sense? And that makes perfect sense if you think about this in the big scheme of things. If I'm writing a Java program, let's say, and I have int A is equal to 5, then I have int B is equal to A, and then I have A equals to 8. What's the value of B?
5.
B is 5. This was a static declaration, right? B got equal to A at the time that B was being defined. And at that point in time, A was 5. B is completely unaware that later on A changed. Does that make sense? So really, the correct way of handling this is at the time that we define B, at the time that we are adding it into our environment as a scope, we need to replace A with its value. Make sense? How do we do that? Go ahead.
Check your environments for operators like the plus sign, things like that. Well, I guess if you're dealing with the math, one before where it had a math expression.
Yeah. I'd say let's solve it for the simple case first, and then we're going to find that the math expression really isn't any harder. Go ahead.
If you have a two pair like that with B and A, if the second isn't a literal, then you just hunt down what that symbol's corresponding literal is.
You mean var expression?
Yeah.
This guy?
Yeah.
Okay. Yeah, literal would be like this. Would be a 5.
Well, I mean, since like in that.
Oh, you said if it's not a literal.
Yeah.
Okay. So if we're not looking at something like a 5, then we need to do something about it. Okay, so we need to go through every variable defined in a scope. Whether that in our current example is a bunch of one scopes or a list of 10 variables, whatever it is. We need to look at every single value associated with variable names in a scope and determine if any of them have a value that is not a literal. If it's not a literal, we need to do something to it, right? Okay. What would we do to it? Go ahead.
You scan back, or then start back at the beginning of the environment and see if that not literal occurs as the first element of the to-list. And then if it does, find what the second element of that to-list is, and then set that what was that not literal there to the literal that corresponds to it. Sorry. Basically, hunt back through the list. If you find A in the first position, then set A where it occurs next to B to the literal that corresponds to A where you found it earlier in the environment.
So I have that guy. And I want to make this so that I can actually have a fighting chance at getting the value of A. What if I did something like this? Just call it a wrapper. Oh, we don't even need the, yeah, we do. All right, so what we want to do is we want to go through and we want to call parse Simon on the second part of each of these guys. So I don't even need an environment here. So I'm going to cons parse Simon I can actually make this even easier. We'll do this. Find wrapper to take a list, and this is actually going to be a toList. And what I'll do is I'll call parse Simon on the catter of the list. And then what we can do is we can map wrapper onto sample env as an example, which then shows that we have a lit expression and a var expression. That make sense? All right. Now, what we can actually do is we can create a list in here of the car of LST with the parse Simon of the second half. And now what we get is we have a replacement environment with our variable name and its value as Bazel code. That make sense? So this is a literal 5, and I guarantee if we pass this to apply Simon, or apply expression, passing Bazel code that looks like this, it'll boil down to just a 5, which is what we had before. A little bit more of a roundabout way, but by doing that, what do we now have? We have the ability to look up vars. That makes sense? So by filtering everything through this wrapper initially, all of our values are now applicable expressions. Expressions we can pass to apply expression. Bazel code expressions. So you might say, instead of calling this wrapper, we might call this pre-process scope, like this. All right, so we might call this pre-process scope. And pre-process scope is going to take in as a parameter a scope. Actually, this will be slick. We're going to make this as like a, we're going to use our let to make this epic. So I'm going to just get rid of all that. The code's going to be almost identical. I just wanted to get rid of it. So I'm going to create a let here. And what is let going to have in it? Let is going to have in it, we're going to have a function called wrapper. Wrapper is going to be a lambda that's going to take in a list. And what's it going to do with that list? It's going to create a list out of the car of LST and the parse Simon of the catter of LST. Okay, so that's our let environment we created there. And then what are we going to do in the body of this? We are going to have a lambda that takes in a scope. And we're going to map wrapper across that scope. So I'll call this variable up here, sample scope instead of sample env, just so we can see how the example would work. And then what we'll do is we will call preprocess scope, passing it our sample scope. Oh. There we go. So by pre-processing that scope, what did we do? We created a pre-processed scope. Looks just like a scope of old, except all the values are now Basel expressions. That make sense? And what can we do with the Basel expression? What's the advantage of having something as a Basel expression? Go ahead.
Technically, wouldn't need to use a scheme to parse it. You could have some of the language parsers if you wanted to.
Can we be a little more specific?
It's abstracted because you have each. It's an example of data abstraction. You have each part of the parse so that you finding a unparser in some other language.
We could call our apply expression. Well, exactly what you're saying. You're just talking about in this generalistic term. Right? If we have Basel code, what can we do? We can throw it at apply expression. So if I have a current environment and I have some Basel code, I can pass that Basel code and the current environment to apply expression and get a value out of it. So assuming we had the current environment and I passed this Basel code, and what would I get? Actually, in that particular case, it doesn't matter what your environment looks like. What would apply expression boil down to for what I have highlighted? 5. That's it. It's a lit expression. 5. What would apply expression boil down to for this guy? Now, it depends. It depends on what the current environment looks like, right? If we do this in the right way, if we're clever enough, since we're piecemealing our environment apart, and we already have a scope that we put in there that looks like this, at that point in time, what do we have? Now, I can get the value of B by resolving this variable inside of an environment that has a scope that's already been evaluated for this guy. And it should get me the value of 5 for A. Does that make sense? So we're taking our two solutions. Tina's solution of let's break our scope up into individual pieces and add them to our environment strategically in a certain order. And we're coupling that with, now we have all of our values being represented as Basel expressions, as Basel code, that apply expression knows how to deal with. That make sense? All right, so what we're going to do, because I would literally be wasting my time giving you an assignment over break, especially this assignment over break. We're going to come back on Tuesday. We're going to talk about this, and I'm going to give you an assignment for Thursday. I'm going to take us a certain distance, and then we're going to do some more. That make sense? All right, get out. Isn't this cool stuff?
You scroll to the
No.
right.
Can you copy and paste this and just post this?
Like you're going to look at it, you didn't know if you have homework assignment.
Yeah, but I'll look at it in my next class. we just take tests in that class.
Yeah, well,
Yeah, V-test.
why don't you look at the video so you can look through this?
Okay. I'll listen. I'll even listen.
Well, then you're like committed to like watch the whole thing.
It's on YouTube. You can scroll through it.
Okay. Although good looking at the video is like
Make sure you click on all the advertisements, though.
Brought you by this.
What's up? Oh, brought to you by Nabisco. There, I do have ads in there, I think, now.
Yep.
Do I? Have you seen them? Did you click on them?
I didn't see any.
Watch. So